Okay, so what we're going to be talking about tomorrow in class, and we're going to do some practice with, is a problem-solving method called dimensional analysis. Dimensional analysis is also known as the factor label method of problem solving. In chemistry, it is a requirement that students learn how to solve problems using dimensional analysis. And the reason why is because later some of the problems that are unique to chemistry are best solved in this method, and this method provides not only a solution to the problem, but the solution also shows a proof of how that solution came about. So it's a way that you're actually showing your work for anyone who sees the solution to the problem. It's a problem-solving method that uses ratios, and what I mean by ratios is something that has a numerator and a denominator. Numerator, denominator, okay? When you first learn how to do dimensional analysis problems, you learn using problems that can be solved other ways. And so many intelligent students find this frustrating because they know they can do it another way. And that's true. There are other ways to solve that problem. But they're missing the point because this work that we're doing is not just about getting that answer. It's about learning to solve problems and communicating that work with dimensional analysis. This is very important. So please smile, because this is the way you're going to learn how to do it. And once you do, you'll like it. It's just learning this new method, just like significant figures. It's just that it's all new that's upsetting when we haven't seen it before. So there are some basic algebra facts that I'm going to review with you really quick. These are things you already know, and they're the reason why the dimensional analysis method of problem solving works. So in algebra, we know that if we take 1 and multiply it by a number, and my dot is my time sign, 1 times 8 is equal to 8. 1 times 45 is equal to 45, okay? 1y is equal to y. 1x is equal to x. So when we multiply a value by 1, we don't change the value at all. That is the first thing that we want to remember that comes from algebra. The second thing that we want to remember that comes from algebra is if we have 7 over 7, and the numerator and the denominator are identical, that gives us something that has a value of 1. So x over x has a value of 1. Y over y has a value of 1. Whenever the numerator and the denominator are identical, we have a value of 1. So we know that if we take x over x and we multiply it by 8, since x over x has a value of 1, we get 8. We haven't changed that value at all. The last thing we want to think about is that if a is equal to b, then a over b is equal to 1. That's important. We want to think about that for a minute. If a is equal to b, then a over b is equal to 1. So if that's true, then we know that we can take a over b and multiply it by x, and since a over b has a value of 1, we're going to get x. Why? Because 1x is equal to x. A over b times 8 is going to give us a value of 8. Why? Because a over b is 1. This is the backdrop as far as algebra goes to why the dimensional analysis method works. We use ratios, and by a ratio, I'm talking about this a over b, that have a value of 1. And whenever we multiply something by a ratio that has a value of 1, we're not going to change the overall value of our measurement or our number or what the topic is there. So here's a couple of examples of problems that I know you can solve already. How many eggs are present in 54 dozen? I know that you can take 54 dozen and divide or multiply by 12. There's 12 eggs in a dozen, I'm sorry. And what we know by thinking about the relationship between eggs in a dozen is we actually know a ratio. We know that there are 12 items, in this case, eggs, in 1 dozen. It doesn't matter what we're counting. There's 12 in a dozen. So in the dimensional analysis method, we start out by writing down the number and the value, or the unit, that they give us. And then we multiply it by a ratio, and what we want is we want the word dozen to be in the denominator of that ratio, because our plan is for that to cancel out. And we know that there are 12 eggs in that dozen. 54 times 12, we're multiplying, if you want to see an X in there. 54 times 12 is 648. We're going to multiply everything that's in the numerator, 54 times 12. The only number in the denominator is a 1. And our answer then has the unit that's left there. 54 times 12 gives us 648 eggs. Now, if they're asking us how many dozen are in 5,000 eggs, we instinctively know that we're going to divide by 12. But once we're doing chemistry problems, we're going to be dealing with things that we don't instinctively know the answer to. So with the factor label or dimensional analysis method, we start out with what they give us, and then we're going to use an equivalency statement turned into a ratio, and we want the unit that we start out with to be in the denominator, because we know we're going to want that to cancel eggs. Okay, we know there's 12 eggs in 1 dozen. The unit of eggs cancels. 5,000 divided by 12 gives us an answer of 416.7 dozen. We show a number and a unit in our answer. The unit that didn't cancel is the one that's our answer. That's what the dimensional looks like. And here are some conversion factors. These are conversion factors that take us from a non-metric unit into a metric unit or back. So we know that if A is equal to B, then A over B or B over A are both ratios that have a value of 1. So if 2.54 centimeters is equal to 1 inch, then we can take that equivalency statement, this one here, and we can turn it into a ratio, and we can put 2.54 centimeters in the numerator over 1 inch, or we can put 1 inch over 2.54 centimeters, and these are all ratios that actually have a value of 1. We can multiply a value by any of these ratios, and we have not changed the value of our measurement. So how do we do this? The first step, we write the known and we identify the unknown. Here, how many inches are in a measure of 97.3 centimeters. We know we're going to start with centimeters. We want our answer to be in units of inches. Chart that we just saw, and we look for a relationship between centimeters and inches. We're going to put this ratio or conversion factor into our work in such a way so that the unit that we started out with, centimeter, is in the denominator because we're going to want those to cancel. Then we're ready to cancel our units and do the math. When we do the math, any number that's in the numerator is going to get multiplied. 97.3 times 1. Numbers in the denominator also get multiplied together. So what we have is 97.3 divided by 2.54. Of course, multiplying and dividing by 1 does not change the value. So when we multiply this and divide this into the calculator, any numbers that are in the numerator will multiply together, and then we'll divide by whatever's in the denominator. What about the rounding? Well, I'm going to round this number that the calculator gives me to 3 significant figures because I'm going to match the 3 significant figures that's in the original measurement. You don't have to worry about rounding just yet. I'll show you how I'm rounding as we go through some problems, and then I'll expect you to understand the rules for rounding a little bit later. So there's 5 steps to this dimensional analysis. Start with the value that you're given, that's the known. Draw the dimensional lines. Insert the unit relationships, cancel those units, and then do the math. Okay, here's an example. How many quarts are in 2,000 milliliters? We need to go back to the chart to look for a relationship between milliliters and quarts. And the relationship that's in that chart is that there is 946 milliliters is equal to 1 quart. Now this can be turned into a ratio with milliliters in the numerator, or it can be turned into a ratio with milliliters in the denominator. How do we pick what kind of a ratio we want to use? We're going to use a ratio so that the milliliter that we start out with will cancel. So when we put this into our work, this milliliter is what we want in the denominator, and we want quart to be in the numerator. So we're going to use a 1 quart per 946 milliliter. Again, we want to use a ratio that works so that our units cancel. Then we do the math. This is basically the same as 2,000 over 1. So we're going to take 2,000 times 1, and we're going to divide that by 1 times 946. So we're basically taking 2,000, dividing by 946, and we get 2.114164. What about rounding? Well, if you got here, I'm super proud of you because you're doing this right. 2,000 only has one significant figure, so we round that to one significant figure to match the original measurement. But right now, the key is that you're understanding that we used analysis to solve these problems. Another example, we have 81.82 kilograms. We want to convert that into pounds. What do? Well, we need to look for a relationship, and on the chart, we see that we can take 1 pound, and we find out that that is equal to 454 grams. And we have another relationship that says 1 kilogram is equal to 2.20 pounds. Okay? Since we're trying to convert from kilogram to pounds, our best bet is to use this relationship, because otherwise we have to convert kilograms to grams first, and that's a little more work that we want to do right now. So here's our relationship. We can either write that ratio with kilogram in the denominator or kilogram in the numerator. We want kilogram to be in the denominator so that it'll cancel with our unit here. If we put our ratio together so that kilogram cancel, our answer is going to be in pounds. So there's the numbers, 2.20 pounds per 1 kilogram. We cancel our units. We do the math. 81.82 times 2.20 gives us 180.004. What about the rounding? There's 4 sig figs in our measurement, so we're probably going to want to round that to 4 sigs. Again, if you are getting the answer and you're not sure about rounding, you're 100% where you need to be right now. Again, all of these ratios have a value of 1, and they can be used in dimensional analysis to solve problems like these. Now this is your homework. You're going to try these 2 problems, and you're going to try to do them with dimensional analysis. If you need to see another example, I'm going to do one more example here. If you don't, you're ready to do the homework. Take a screenshot of this or write down these 2 problems on your own loose leaf paper and solve those problems using dimensional analysis with the conversion chart that's here in the video and also posted on the website. Okay, I'm going to do one more for you, and it's not going to be typed, I'll just write it out. If a string is 798 inches long, what is its length in meters? So I know I'm going to start out with the value that they give us, and I'm going to put the unit in. That's how I'm going to start. I'm going to multiply that by a ratio, and I already know I'm going to want inch to be in the denominator, and I'm going to want meters to be in the numerator, because that's what the question's asking me to get for my answer. So I'm going to go back to that chart, and what I find is that on the chart it says that 1 meter is equal to 39.4 inches. That's my conversion factor, and I'm going to put that into my problem. I'm going to put the 39.4 in the denominator. It's equal to 1 meter. Now I'm going to pick up my calculator and I'm going to do the math. I'm going to take 798 and divide by 39.4, and the calculator gives me a value of 20.253. Now I'm going to round that to 3 significant figures because my original measurement has 3 significant figures. So my answer, I'm going to keep 1, 2, 3, 5 is big enough to make that 2 round. So my answer is 20.3. Make sure my point came out. And my unit is meters, because inches canceled. Okay, I hope that gave you a little bit of an introduction to what we're doing tomorrow. I know that you're going to have questions when you get in here. Hopefully you've tried those 2 problems. Look at this as many times as necessary for help. Come in, bring a calculator is a great idea because it's hard to do math without one. And we'll be looking at this dimensional analysis method and using it throughout the school year. Have a great night.